Hi friends, welcome to the Unit 3, Day 5 Notes, Graphing Rational Functions. Number 10, this is h of x. h of x equals 3x squared minus x minus 6 over x squared plus x minus 6. So we're going to start by finding the vertical asymptotes first. Going through and factoring it, the numerator doesn't factor. It's going to stay as 3x squared minus x minus 6. The denominator does factor. We've done this a few times, x plus 3 and x minus 2. So the vertical asymptote, nothing's going to cancel for the whole part. So we're going to go ahead and just set the denominators equal to 0 and then solve for my vertical asymptotes. So I get x plus 3 equaling 0 and x minus 2 equals 0. So I get x equals negative 3 and then x equals 2. So my two vertical asymptotes are x equals negative 3 and x equals 2. Again, using blue. Did I use blue? Blue for my asymptotes, yeah. So there's that. And here's this one. So we have two vertical asymptotes. In this case, it's going to change what happens with the shapes of the graphs. My horizontal asymptote, so I look at the degree. My numerator and denominator are both the same degree, so I just simplify the leading coefficients, and I get y equals 3 as my horizontal asymptote. Now we're going to find the y-intercept, if there is one. So we're going to find f of 0. So if I plug in h of 0, in this case, everything zeroes out, and I get negative 6 over negative 6, which is 1. So my y-intercept is at 0, 1. Forgot to switch over. This is actually in the graph, so I'm going to graph it. This is on the graph here. Okay. Find the x-intercepts. So here, remember we take the numerator, set the numerator equal to 0, then solve. I already told you that this was non-factorable, so this is just a, in this case, this is just an exercise in the quadratic formula. So go ahead and try it in the quadratic formula first, before you continue. C equals negative 6. So I get x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So simplifying this, we get 1 plus or minus, I'm going to simplify everything inside the radical. Again, I'm doing this to save space. 1 plus 12, 72, 1 plus 72, 73. So I get 1 plus or minus the square root of 73 all over 6. So this is going to be irrational. So at this point, for graphing, because I want to get kind of as close to it as possible, it looks like I'm going to have something really close to, did this earlier, x equals, so it's approximately equal to negative 1.3 and then approximately equal to 1.6. So these are my x-intercepts. So these points, 0, sorry, other way, negative 1.3, comma 0, and then 1.6, comma 0. Like that. So seeing that this here, now I have points in this region, tells me that I'm going to have points in this region here, and then this region here mostly. We'll jump into that. Well, I know that here in a second after we get to the graphing part. But we've got a lot of points in that middle region that we can use to graph. Now we want to determine if the graph is going to cross if it crosses. So I'm going to set 3 equal to 3x squared minus x minus 6 over x squared plus x minus 6. So I need to multiply both sides by that x squared plus x minus 6, which we've done. So this cancels that. I end up with 3 times x squared plus x minus 6 equaling 3x squared minus x minus 6. Then I distribute the 3x squared plus 3x minus 18 equals 3x squared minus x minus 6. Subtract 3x squared from both sides. Let's go ahead and add x to this side, and then add 18 to both sides. So I end up with 4x equals 12. Divide by 4, and I get x equals 3. This is not a whole. X equals 3 is not a whole. So going back here, what I have is that this is going to cross. This is going to cross at x equals 3. So this is going to cross here. So this is a point. So I'm going to have a point at 3, 3. It's going to cross over that particular value there. I know that because I got x equals 3, and x equals 3 was not already a whole. It was not already a point in the graph where there was a vertical asymptote. So that tells me that it is going to cross. So this is the first time that we've had this scenario. Go back and double check, kind of read through these steps to see, okay, why did it cross? Why did it cross on 10? And then review, why did it not cross on 9? Because on 9 it didn't. And then now we just need to get some more points here. So it looks like, again, I'm going to grab kind of a t-chart to find this out. Because I have my values here, let's go ahead and start. So negative 1, 2, 3, 4, 5, 6. I'm going to do negative 6, negative 5, negative 4. That's going to give me this region. I feel like I already have enough here in this region, but I'm just going to go ahead and just ensure that I do by plugging in negative 2, and then let's do 1 as well. And then for this region over here, let's see, 1, 2, I already know what's going to happen at 3. So I kind of want to see this. This should go up here, so I'm going to verify that by doing 2.5 or 2.5. 1, 2, 3, 4, and 5. Okay, so I feel like that's enough to go through. Again, I would pause the video, check, plug these in, make sure that you got it before you continue on. For time space, I am going to pause the video here. I'm not going to show, I've already showed what I do by plugging in each of these values. I did that for number 9. I don't have enough time in the recording to do that. So I'm going to pause, and I'm going to jump back here in a second with all of these filled in. So see you in a bit. Or in this case, it'll just jump cut to the next part. All right, here's my jump cut here. I went ahead and filled in these. I also put approximately equal. This particular problem, with all of its intricacies, gave us some values that were really close. So now plotting these points on the graph, negative 6 and then 4.5. 1, 2, 3, 4, 5. So that's about here. And then 5.3. And then 7.7 is actually off the graph. So this here goes up pretty quickly. This one, I've actually picked those 2 points on purpose because 1, 0 makes this sort of thing. Here, it actually barely just goes above these two, but those two values are the same. And then I get, again, close to these asymptotes. And then over here, 3 points. So here, 1, 2, 3. I have this scenario. So across, like we mentioned earlier, I'm going to go down, but then it just kind of hovers around this asymptote. The asymptote, remember we talked about how things get really close to it. It's kind of an attraction. So the graph is attracted to that asymptote. So even though it goes and crosses below it, it actually wants to be as close to that asymptote as possible. So even though it comes down, it actually swings back up and approaches it again. All right, well, hey, there's number 10. I'll see you in the next video.